Hello, welcome to another Knative from the couch. I am so laggy right now. This is killing me. At least in my own video. So I have audio, but I'm gonna have to catch up here, and it'll come. Anyway, I'm just gonna keep talking because you all can hear me hopefully. So thanks for coming, and I want to welcome Chris to his very first Containers from the Couch as a DA at the AWS Kubernetes team. So welcome, Chris.
Thank you. Thanks for having me on.
Yeah, and Carlos, thanks for coming too. Carlos is going to show us all about Knative today.
Woohoo!
How you doing, Carlos?
Hello. Doing okay. Hey guys.
So a couple things I want to talk about. It looks like my video is catching up, and so I'm just not going to look at myself. Yeah. I wanted to call out a couple things for anyone watching the show live. Thank you for coming. Right now it's November 15th. We have two more shows this week, which I'm pretty excited about. One is HashiCorp Console Service Mesh with ECS on Wednesday. Adam is doing that. If you want to get a reminder for it, we have it on YouTube, but also you can join live here on Twitch/AWS, showing off console. And then on Thursday, Adam and I are going to actually do what we call the pre-invent. Hey, Brent, what's going on? I finally popped over the comments. How's it going, Brent? We're going to do a pre-invent show on Thursday, talking about all of the container related topics and releases we've had at AWS in 2021, not the last year. We're not going to go all the way back to 2020. We're just going to forget that year as much as possible. And 2021 releases, we're going to go over a bunch of stuff on Thursday. So if you're interested in just catching up on AWS news, container stuff, we are going to have a fun show on Thursday, just going through as many of the cool things that we want to show off. But for today, if you know about Kubernetes ecosystem and you know about serverless containers and running it yourself, Knative has been in the space for quite a while. And what was it, Carlos? It was like 4 weeks ago that Knative went 1.0?
Yes, 1 week ago.
It was only a week ago? Oh man, so I was
2 weeks ago. We worked for the release like 3 weeks ago, but yeah, we got it out last Tuesday was the ship it Tuesday.
Well, congrats on that, because it's exciting to see it come as a 1.0 release and seeing just how far the project itself has come. So I was really looking forward to when I wanted you to come on. When I saw that was coming, I was like, we really need to talk about this, because I think people are interested in this space, being able to run your own serverless environment on top of Kubernetes, reuse some of that compute, and then some of the different kind of constructs and abstractions that Knative brings into play with eventing and serving. So I'm glad you're here. Show us more of that. If anyone was actually interested in seeing me stumble through it on my own, I was relearning some of it on my own personal Twitch stream last week. I stood up a cluster with kubeadm on a Snowball Edge I have in my garage, which was a lot of fun just to go through that process. And then the last thing I was doing was actually trying to get Knative installed, and I got it installed, and I fumbled through a lot of the demos for myself as I just didn't know some of the space well enough. And so I found myself going back through and figuring out what is that next piece of what do I do from here? How do I use the tool now that it's installed and up and running? So Carlos, I know you have some demos for us today, which I'm excited to see.
Yeah, I need to subscribe to your Twitch channel so I get notification.
Yeah, I just did it. I didn't realize you had your own thing.
Yeah, I could join and we do it together.
Yeah, I don't do it often. It's usually just me working by myself. It's when I'm trying to figure out something. It's not like flashy. It's nothing that I'm just like, I need to figure out how something works. I'm going to sit down and just try it for a little while. And sometimes I'm willing to be embarrassed while I try and stumble a few times. So this actually took 3 videos to first learn the Snowball Edge, how to get a custom image installed. I did also install EKS Anywhere on it. It's just like a single VM instance. But then what I really wanted was I had a 4-node Kubernetes cluster with kubeadm was like the final stage of what I was working on. So with the goal of I wanted to get Knative installed. So I think it was Thursday or Friday when I finally got Knative on top of it. I was able to use APIs. The CLI was working, but I kind of fell apart on my own learning just because I limited myself to, an hour or so of doing it. So this is prepping myself for this show, which I'm, again, excited just to see how far it's come and what you're going to show us today.
Yeah, excited to be here. And
so why don't we go ahead, and I don't see any, if anyone has questions for the 3 of us, Knative, or anything else related, go ahead and drop it in chat. Happy to bring those in. And Carlos, let me get your screen going on here so we can jump into just some of the overview on Knative and then also the release. There we go.
Very good. Let's see.
Let me get this couch out of the way here.
Oh, there you go.
There it is.
Yeah, so this is Knative 1.0. We released this last week. The release is kind of putting a sticker on the release because we have APIs. If you're familiar with Kubernetes, when you create CRDs, at the end of the day, this installs a couple of CRDs, and those CRDs have versioning. And in Kubernetes, usually we name those versions like V1 Alpha 1, V1 Beta 1. And in Kubernetes, there's still things that are V Beta 1. So the things that you're familiar with as a Kubernetes admin deployment went through that process, right? Things that you use every day, they went from being an extension to being core. So in Knative, we wanted to release 1.0. It was going to be 27, so we were doing a lot of releases like from 0.1, 0.2, 0.3, and the thing that we did was release every 6 weeks, something that we took to heart. Like every 6 weeks, there's something going out. So we didn't, adopt semantic versioning, but we adopted like Kubernetes release cycles as much as possible. But every 6 weeks, we had a release out. We cut a release, and things that included the release was going to be patches and minor features. But between those 6 weeks, we have some automation that we cut a branch, and then that will do a patch release, whatever is in main, like in the upstream in main, it will cut it and we'll do a little patch if there's something in there. But usually people waited for that 6-week release, where we also took the website and we revamped the website. The website didn't look like this, like I will say 2 months ago. So we moved from one system to another one to make it easier for the technical writers to work with Markdown versus some other like framework. So yeah, we were able to release it, and we did a couple of as part of this 1 point release. One important thing that we did was we have 3 committees in the project. We have I would say similar to Kubernetes. We have we have a steering committee like the TOC, Technical Oversight Committee. We have a steering committee, and then we have a trademark committee. And the trademark committee, the individuals there, they put some rules around like what does it mean to be 1.0, like what are the gates. So they went through a whole spreadsheet of all these gates like we needed to meet, and one of them was documenting the APIs. So you're going to have an API 1.0. First thing in there was, are the APIs documented? Another one, for example, was conformance testing, like actually testing that the API says what it should say. And also that conformance testing is for anyone that wants to implement Knative. And we have folks like Red Hat that does OpenShift. They have an operator serverless. Maybe Chris knows about it. They say that they have Knative. So if I take my Knative app to an OpenShift cluster running on any cloud, for example, I have an AWS, an OpenShift cluster here running on AWS, my Knative service should work like it runs on Minikube in my laptop, right? So that's one of the things that we did with the 1.0. The other thing, and for anyone that wants to have like that conformance, like Kubernetes has a conformance project that somebody says I'm a downstream of Kubernetes, I'm certified, I meet these guidelines. Another person a vendor can say, we have a system that you can bring your Knative either serving or eventing, and we wanted to release both. Eventing serving at one point was more mature, had more testing, it was more stable, was declared V1, and then later eventing eventually declared V1, meaning like these APIs are not, we're not going to do breaking changes. That's it. The one thing that was new for the website, also for 1.0, that I was involved was case studies. So if you go to the homepage, I think Chris share the site. If you go to the site, was having case studies, and this was kind of like an important thing because, and we're doing more case studies with more users, either a somebody that is like implementing a service with Knative, but we're talking to folks also that like using Knative inside the company for the developers inside the company. So we have people like DeepSea, Puppet, Outfit, and I will continue doing that. And we had like a conversation asking them uh, why did they choose Knative, what are the benefits that they took, how they're using it internally. Outfit 7 is a cool company. I'm familiar because I have a 15-year-old daughter, and when she was a kid, she was using this iPhone app that came out, like this Talking Tom or something like that. I don't know if you folks have kids, but it was these apps that there's a little cat that talks, and um, I know I noticed that they're using Knative and they're using it heavily at a high scale. So that was one of the things that it was part of 1.0, like that release of going out and trying to see if people change that mindset of saying, nah, I'm not going to give it a try because it's not 1.0. Like, nah, I'm not going to give it a try because it's not 1.0. And now it's like, it's it's 1.0. So can you give it a try and give feedback, right? Um, and put it on top of Kubernetes to see if it helps you with your Kubernetes workloads, either increase the density, right? Get more applications. I usually talk about the density, and we can talk about that, about the two systems, but the density of having an application declare or install. It's like if you have an iPhone app or a mobile app or phone, and you keep installing applications in your phone, not running all the time, right? You have, I don't know, I have like 60 applications in my app that I installed a long time ago, and I never launched them, so they're not running. They're not consuming CPU or memory, right? Or most importantly, CPU. So I can have more density. I have storage in there, so I can have a lot of apps. Same thing with Kubernetes and Knative. You can start declaring all these applications, and if they don't get used, at least in serving, um, they're just there, right? They don't consume any CPU or memory, and you can have all these applications defined in the Kubernetes cluster and scale them from zero, which is
Now,
an option. Like, doesn't have to be scaled to zero.
Carlos, one thing that I think is interesting about Knative is it's used by end users in some cases where it is here's a complete system that you can install on top of Kubernetes and just run with it. But as you mentioned before, things like vendors, OpenShift, Google, some other IBM, like there's vendors that are using Knative to build more hosted services and maybe even add more layers on top of that. Is that correct?
Yeah, exactly. I'm more familiar with the OpenShift and the IBM because that's where I work. But I was the architect for a system that we still have called IBM Cloud Functions, and we created a new system called IBM Code Engine, which is the next generation one because Functions didn't have support. Let me see, for like WebSockets or persistent connections. a let's see if I have the example here.
Well, and like my point was the fact that lots of people can use this. And so some people use just bare Kubernetes, right? They just like, oh,
Right.
Kubernetes is good enough for developers. People can just figure out kube control and run with it. And that's
Oh no, yep.
maybe that's good for some people, but not for everyone. And in this case, like you can install Knative, you can have the KN CLI and just use it if that's where you're at with how you want to use it. But if you also want something that's more polished, something that's more integrated with a broader provider system, you can use essentially a hosted version or a supplied version of Knative on top of Kubernetes or whatever that cloud environment is as well.
Yeah, you can implement this API on top of Kubernetes or your own bytes. Like I was saying, in Code Engine, we abstract Kubernetes, so you don't see Kubernetes. You just give us a container somewhere, or you give us a GitHub repo, and then we give you back a URL, right? That you
Yeah.
can access a website. Same thing. Some platforms are doing internally because they have like an organization that is the developers, and they will have an organization that is called the DevOps, right? The platform team.
Yeah.
And those platform teams want to give like a better user experience to the developers, saying, put your code in GitHub, or make sure you create a good container with your CI/CD pipeline. The deployment process is going to be a little bit more simpler, and also the rollout of having traffic splitting and be able to do a rollout based on a time window, which we support in Knative. You can say, um, for the next hour, start incrementing um, the percentage of the new version of the application, and not just go from zero to everything, because then you have a lot of pods to like scale instantaneously.
Yeah.
So you can program that in there. So some systems are providing an integration, like you said, integration into their platform. So they might have like a storage system for events, or they might have a secure registry. So having that integration and abstracted from the developers, kind of like the experience there. But it's built on top of Kubernetes. That's the reference implementation that we have in the Git repo and the containers that we provide.
And the tech guy here asks if eventing works on AWS, and I know it does because we'll have a demo for it in just a little bit. So, but let's, even before we jump into the demos, Carlos, give us just a brief overview. I see you have it up here. Serving versus eventing. Why do both these things exist inside of Knative? Like they seem like they're separate things, but what's the point
Yeah.
in having them both integrated here in one project? And how do they both work?
Yeah, so the if you will go to Knative, actually you can say there's two projects in there, and I think that the reason I would say the reason they're under Knative, because it was the same people and the same code being used in both projects. There's a common layer that we call PKG in Go, that to create these controllers, the way these controllers CRDs are created, we don't use the operator framework or Kubernetes or those tools. We have our own system to create controllers, and we share that code. So to create a controller in Kubernetes to have like leader election, and you can do sharding and do HA to spread the work between operators. Usually it's just standby, but we create one that can scale, because we needed to scale some controllers and some data planes. Was that the other than that, like the bits and bytes for the nerds like me, like look at look at code is in serving. Basically you have source to URL, and that's the net of it. You have a container or source code, you build a container, you get a URL. In eventing, you handle events, and those events are cloud events, and they're sent to a handler. That handler is a URL. So the thing is, and we did it purposely. It used to be a time that you needed to install both. So I think maybe people that tried Knative in the past was like, why so heavy? One of the things that we also would remove was the requirement for Istio, but that's another story. But you needed to install, for getting eventing, you needed serving first. And what we did was we decoupled that. And what we said was eventing now, when there's an event and you want to call a function or service that's handler, it's a URL. And in the system inside the Kubernetes, we can detect if a service has a URL, it's that we call it addressable. We can detect if a Knative service is addressable because the CR can give us the URL, or this handler could be just an external URL to something else sitting on another cloud, for example. So that's the connection that what people do with eventing and serving when they have eventing and they want to bring serving is because when they're handling events, they want to call a Knative service that will scale from 0, handle the event, and then if there's no more events to handle, just goes to 0. So that's really the connection, but you can use them separately. And one is to handle events. It happens that like I said, the URL that you're calling, it might be a Knative service, but it doesn't have to. And then in serving, there's no requirement on eventing from service. Serving can be just called by itself. It's just scaling up and down a container. Does that make sense? I think that was kind of the one at one point the confusion some people had, that to get eventing they needed to install serving because of that coding. But we made the doc typing, we call it, like to detect if something is addressable, and we can send a cloud event to it.
Yeah, and you brought up the point, like the first time I tried to run Knative, I got stuck on Istio. It was like, okay, get a Kubernetes cluster, have Istio running. Now you can try Knative. And I got stuck. I was like at the point where I was just like, I can't continue doing this because I couldn't get past that. And so knowing that those are separated things now and not requirements is really great. Also, Kubernetes has gotten easier to create clusters and kind of manage them. But dig in a little bit here on the eventing piece. You mentioned cloud events, which I'm pulling in here. What is that? Like, what is a type of event? I know there's a standard for it, but so we can explain, like, why would I want to trigger something based on some random event?
Yeah, if we look at eventing, let me see if I can zoom in. You see this? Yeah, in eventing, what we have, let me look what's because I have a thingy here, a pointer. It's not working. Oh, Control F. Hopefully this thing. So eventing, basically what it is using cloud events, and you put the link there. And cloud events is the way we use it. They have multiple protocols like Kafka and others, but the one that we use is an HTTP post. And for example, GitHub, when you have a GitHub and they support webhooks, it will send you a post with some data, and it has JSON in it. And you have other systems that this is basically the webhook kind of terminology out there. But there was no standard of like the payload and the headers of that JSON. So everybody, you go on all the websites or integration website or GitHub, and you start reading like webhooks. Okay, we support webhooks, so you can do anything with it. Then the next step is like, okay, you will call me with an HTTP post, and there might be something inside that body JSON and headers, and I just need to parse it. So what Cloud Events did was trying to see if we can come with a convention of specifying those headers, like where's the source, what's the type, so we can do filtering. So that was kind of the basis of it. But it's no more complex than having an HTTP post. It has some SDKs for the different languages that it will send you a payload in HTTP post. It could be application JSON. And then basically you want to do, and we have a system here in eventing that we have a broker and triggers, and we have a filter. So you can filter based on the source, like where this event is coming from. It can filter based on the type. So where do you get the type? There's a header called CE type, right? It's not like that complex. They didn't come up with like, we need a better way of doing it. Just they need a like consistent way of doing it. So what do we call the source? Well, let's call it CE source. And the timestamp, right? Those type of typical information. And then you send it. So that's the way of we're handling. So we have a way of like sources. And I think you asked like, what are the type of sources? And sources could be things that pull from something like in this example that I show here, like is going to a bucket, to an S3 bucket, and checking there's a new file. And if there's a new file that start with this prefix, then it would like read the file, and then you can configure the source to say like, hey, delete the file because I already consumed that, and then send that as a cloud event to a broker where there's some triggers filtering, like, I want to filter that event based on the source, the type, or extensions, anything that I want, and then send it to a handler to handle that. And I have an example I want to show it, where if somebody puts a file in a bucket, then you want to have that cloud event go through the broker, which is kind of a hub. I call it like mesh or hub. You
Mm.
send the cloud events in there. So we have implementations that are, the API is the same, and the behind the scenes that is implemented with a channel. So we have a Kafka and RabbitMQ in Knative, and then other providers or anyone can implement a broker using whatever is the persistent layer that they have. So once it goes to the broker, then you create triggers saying that you want to do filtering, and like I said, you send that post, that message is the same message. That cloud event is the message, the payload of that HTTP request. Send it to a URL, and that URL could be a Knative service. It doesn't have to be, or it could be just a deployment, right? You have a deployment, a service in Kubernetes. It's addressable because you can address it with a host name, right, and a HTTP, or an external thing that takes a URL, and then you handle it. So I think I was showing him something very silly here. If you upload a file that says something inside, the broker will send it to a trigger that says if there's a cloud event flowing through the mesh that has these properties, I want to know about it, and go ahead and send it to this function. And I said function because it could be a web server that is wrapped as a function, or just an HTTP web server that is listening for that post, and then basically you send it to Slack.
Yeah.
Hmm.
So that's kind of like why you want to handle events, and it could be anything. I think I have
And yeah,
a long
let's jump
list
into
here
that
in
demo.
sources.
Let's jump into the demo because I think
Yeah.
showing that off would be good, just to like, hey, let's get an S3 bucket or something going to S3, and then what can we do with it? I think is good. And then to your point of putting service, serving on top or connected to this in the same system does make sense, because I need to take those events and I want to trigger something. It could be an HTTP request, but that should go straight to a service, but it could be something else. And a lot of, as more and more things happen in our infrastructure, we want things to be event based, and we want things that can scale to zero, because it allows us to find the flow of how things are happening and saying like, oh, I don't need a long running service to act on S3, and things being dropped in S3,
Right.
I can do something else. And then coupling those together, I can now say, oh yeah, I already know where that endpoint is because I need to do something custom, so I can build something on that. So I think that's a really cool way to, a reason to tie these things together. So we can go ahead and jump into that demo. The last question that I actually have, Carlos, and I think you would be the only person I would ever ask this question because you will have the most experience, is
No.
OpenWhisk versus Knative. OpenWhisk also is a open source, event based, run a function sort of thing, and Knative has that components, but is doing things slightly differently. What is your general just like opinion or take, or like why would someone use one versus another?
Right.
Um, yeah. So yeah, you said like it's the first person to ask. Like I'm the co-creator of OpenWhisk, right? Maybe that's why he's asking.
That's why I'm here asking it.
So yeah, when we created, I'm just not going to give a long history thing, but when we
Hmm.
created OpenWhisk, Kubernetes was not stable and it was not an option. So we needed to create a system. Actually, it looks, if you squint like this, we created that, uh, but it was functions based. That the we I added a container based option, but it wasn't a regular HTTP web server, but it was functions based. So you handled an event. It didn't support cloud events, so we just came up with whatever you put in the JSON, that becomes your parameter. So the convention was, if you have an application JSON, and you send a post HTTP request, the top level JSON fields became the fields. So there's no standard for that. That was one thing. So as I created OpenWhisk, Kubernetes came into the picture, and I can move to serving. And there's some properties in Knative that you don't find in OpenWhisk. And one of the things that in Knative we didn't have was gRPC and WebSockets. And me being a Node.js nerd and being in love with things like Socket.io, I really like, and a web developer, right? WebSockets was, when it came out, I used WebSockets to demo all my mobile apps and web apps. So I was a big fan of WebSockets, but I couldn't use OpenWhisk because the system, the way it scales, goes through Kafka. And I think we did a show, right? I explained all this. They can look in your YouTube channel, where you send an event and there's not a connection, persistent connection to your function, right, or your serverless function. So if you want to get really good throughput and reuse the concurrency of one function, one container, you cannot do that in OpenWhisk. So you have to have a large system, and we have IBM Cloud Functions. That's architecture that we did. But you need to have a large system, multi-tenant system, just in case if there's a lot of load, so we have enough capacity to bring it up online. But it didn't have WebSocket. The other thing is gRPC, HTTP2. Having a connection directly to your function or your web server. For a lot of applications, they need concurrencies. Like there's a lot of application written in C++, Go, Java that is multi-threading. They can handle multiple concurrent invocations in the same memory space, right? With a 250 megs or 1 gig of memory and certain CPU, they can handle that connection. So OpenWhisk didn't have that. So that's one of the reasons I moved from OpenWhisk, that open source project. It was I took it from incubation to graduation, the Apache Software Foundation, and it was a system that was complete, and it has a lot of runtimes. There's a lot of vendors out there, and I moved into a world of Kubernetes. So, like I said, I created OpenWhisk, or co-created OpenWhisk with research, and Kubernetes wasn't in the picture. So when Kubernetes came into the picture, I moved to this team to create kind of like the next generation code engine and use Kubernetes as the programming model, because that way anyone that uses Knative, if they want to update it, if they want to patch it, if they want to monitoring, the answer is like the same way you do Kubernetes, right? Knative is an extension. So,
and I think that's pretty key, where infrastructure has changed a lot, even in the last 5 years, and the interfaces yeah, exactly. The interface that we use and the standards we use to build these larger scale systems has become more standardized. And so Knative is able to build on that. As you mentioned, there was no cloud events, there was no stable Kubernetes at the time. And so you're able to redo and rethink some of what you were doing before and just use the layer lower and say, oh, well, I already get a persistent database in CRDs and Kubernetes etcd. So like, you don't have to re-implement like where you're storing data, where you're fetching that. And it allows for you to move a lot faster with some of that stuff. So let's jump right into the demo too, because I know we're already more than halfway through the stream. I want to make sure we can show it off.
So let's show one cool one. Let me show one that is, I have, last night I was playing with EKS Anywhere, and basically I want to install Knative. I guess you were trying to do the same thing. So I went ahead and created this is a GitHub repo out there that I put, but it's like a half a README file. But I installed Knative, and I'm using multipass because I wanted to test multipass. And basically EKS Anywhere is just Kubernetes, and if you have Kubernetes, you can install Knative, install the CRDs, install your domain name, and then I installed the CLI. And this is an app I think you have, right, out of the box that we can do. So let me see if I do Knative. We make this much bigger. I think this is very tiny for folks. So let me make this super big. You tell me.
That's legible to me.
So this is the KN, this is the CLI. And this is not magical things, it's just like sugar CLI to maybe YAML. to put things together. So the KN is something that I use, but I also can generate the YAML that you can take and put it in GitHubs, right? So a lot of people start with the CLI and they fall in love, but it's good for hacking things and getting things working. I'm a proponent of let's use GitHubs for production. But with that said, if you copy this line, right, it says create me a service, create hello EKS, and this is something that we fix. It used not to be like that. You can specify the port. So this is port 80 and the image. So if I create this container, and basically I'm specifying a container, this will create a configuration. It will create the first revision and give you back a URL. So if I take this URL now and I do a curl and I try to hit it, now is AKS anywhere. That's the output that I think. I don't know if you just created this app.
I did. Those are my design skills right there.
Yeah. So I wanted to use an example that is relatable, right? And basically what we can do is right
now when you're creating this service, just so I can make sure everyone's like I'm on the same page.
Right.
I could do this with kube control. I could create a service. I could expose that service. I get a load balancer for that service, and I could do very similar things. But benefits here being this scales to 0 is per request. When you're sending that curl command, you don't necessarily have a container running. It can start it for you and send back the information and scale back down, right? So you get all of the functions as a service, sort of Lambda style, working with these services without actually needing to like try to do that with your own autoscalers or, per request routing sort of thing.
Yeah, exactly. So out of the box, these will run. You can also configure it to not run out of the box. And by default, in a minute, it will scale to 0. But the idea is that you can set the concurrency. So the default concurrency, and there's a lot of knobs. You can set it to it comes from, I think it's 100. It's the target concurrency. So that request rate, there's a queue proxy next to that pod. So that's what you see for those people that know Kubernetes. You will see 202. So there are actually 2 containers in here. One is your user container, and the second one is a queue proxy. And that queue proxy is sitting there to validate that you don't go over the concurrency. So you don't send more requests that you want to that your container in that pod. And also for the metrics to tell the autoscaler, hey, they can detect that I need more pods. So let me see if this thing is scaled to 0, and we will test it again. So there's no pods. Go ahead.
I was just saying, I love the concurrency because that's what we do in App Runner as well, right? Like the Lambda is it's always 1-to-1, and so you constantly have a function that you need to have small cold start times and everything else. But in App Runner and here in Knative, you can have one always running if you want, so you don't have to worry about the cold start time. You can just say, oh, the first 100 requests or first 1,000 requests, whatever your app can handle, send them to this container, and then we'll scale up after that. We'll say, oh, we need more. Now we can just add the second one, and that can have the slightly more cold start time, because I'm assuming you can also play with like when that's scaling up and when that actually scale happens, and then your request will seamlessly start hitting the other pod as well.
Yeah. So you can, a lot of people, what they do, because they want to have like that functions as a service type of environment, what they do is when they create that YAML, they put an annotation on the service or create the CLI, and they will put scale target, right? There was a scale target of the concurrency limit. So instead of being 100, you can say 1, and make sure my app, and somebody said this in the Knative AMA that we had on Twitter, saying that they want to have their application having one concurrent application because they are afraid, or they're not sure if they get more than one, they're doing things inside that container that will go out of memory, and then the things like OOM. So you can set it to scale to 1 and make sure that only one request is hitting every pod. And also like then it's scale to 0 or just scale to 1. So I can do like KN service update, hello EKS, and then it was what was the option? Was scale, right?
Yeah.
Target equals 1. Now it's one request. It works like a Lambda or OpenWhisk. Like one request goes to that function, and I will call it. I can do curl again against this thing, right? And it goes there. I can do hey. It's a tool that I can say one concurrent for and then it will send a lot of requests, and you will see that that container only process one request at a time, and it went as fast as the 95 percentile was 0.02 milliseconds, right, of a second. So wow, Justin, you write good code. That's very fast.
I love plain text. That's how you do it.
That's the fastest way.
But when you do get pods, right? If I can type, just was one, because it was able. Your app is so fast and so good that it wasn't able to load enough without the queuing to have like maybe 2 or 3 concurrent requests actually go in there to need that second pod. But you can do that. And one of the things that we are doing that we're actually, you talk about OpenWhisk. One thing that we do in OpenWhisk, we do warm containers. So a lot of people are latency sensitive or like that cold start. They don't want to get a high cold start than like that scale from 0. So in OpenWhisk, what we do is we have like stem cell containers that are already pre-warmed without the code. So people have that feeling of like a low cold start. So in Knative, what we have in experimental right now is called the container freezer. So what we're going to do is the code is in Knative Sandbox. So what we're doing is talking to the container D and the C group and freezing the namespace. So there's no CPU. So that way, when it scales to 0, it doesn't scale to 0. What it does is it stops or pauses the container. And that's actually what we did in OpenWhisk. And that's something that we brought. That's not the code, but the idea, we brought it into Knative to see if you hit that container like right away, the memory of that container, that state, if you're doing something stateful, it will be in that container, but it will be like unfrozen. And this is like something talking to container D. So we have implementation with container D and Docker to freeze the container in C group, and that way you have kind of like go start shenanigans or bike sharing, and we can avoid that, right?
Yeah, and that's really cool because I mean, the thing that takes a long time usually is pulling the container, expanding the file system. Like those are the slowest parts of container start. Typically, different applications will have different profiles for that. But if you can get to the point of after the application has started, suspend it, pause the container itself, you already have memory allocation that you just like don't process anything until I tell you to. And you can also clone that, right? Because you could migrate that pause state. You could export the pause and say like, oh, I need to replicate this further, or I need to start another container from that pause state and replicate it multiple times. So that's really cool.
So if Carl, people in the community wants to, learn about that, or they're free to join, right, and learn about this going out of the door very soon.
Carl asked if we're doing anything to reduce the cold start times, or if that's mostly upstreaming Kate's. And I'll just say, in this example, it's my code just being incredibly fast, which
SPR does
is just Nginx and a text file. So in that case, like I'm not doing anything. But if you actually have something like a Java container or something that does have a longer cold start time, I'm assuming in here in Knative, I could say like how many cold replicas to keep, which you're mentioning for the freezer, to say like, hey, I just want these things to be warm. So my next, it's in Lambda, it's called provision concurrency, where I can tell Lambda, hey, keep this buffer ahead of time so that I don't have to have that cold start every time. In this case, in Knative, if your application takes a little while, you can tune some knobs to try to do that, which will be upstream Kubernetes work.
Yeah, you can say scale minimum to 4 pods if you want to keep them running. But like you said, then have the freezer. So the freezer is very new. It's not in the Knative out of the box. It's in the case Knative sandbox as we experiment. But hopefully, it will be out soon. Also in providers.
Yeah, and the concurrency helps a lot there too, right? Because I mean, a lot of times applications can handle more than one request at a time. So
yes, for the most part, yeah. And a lot of people write code like that, right? And a lot of people, as they get started, they don't know how to write concurrency applications, right? Multi-threading applications. Maybe they use a language that is single-threaded, not to name one, but they need that concurrency scaling up and down with the minimum concurrency. So let me show the other demo before we run out of time. So this is Knative serving, right? Give me a container, and there's a lot of knobs in there. I forgot to mention there's a perception of Knative that there's a bottleneck in performance because when it's scaled to zero, let me see, we do zero, right? Who's going to handle the request? There must be some pod that handles that request if your pod is not running. So if you do pod -n Knative serving, there's a component called autoscale, the activator, and his job is to take that first request to scale from zero. So it takes that request and it's like, let me freeze. We're freezing everything. Let's freeze that request instead of the container. Let's freeze that request and tell the autoscaler for this specific app, go ahead and start from 0 to 1 to get the first one, and then proxy the request. So we'll go through the activator, and the activator will load balance the request to the point that you have enough, burst capacity that it takes itself out of the way. So then it's like vanilla Kubernetes. There's no network data plane that Knative inserts while the app is like steady going up and down onto the point that it scales back to 0, and somebody needs to handle that. So the activator is the pod that handles that, and that activator is a data plane, so it scales and you can change the knobs. So
I'm curious what the resource utilization of that activator is. I'm sure it's next to nothing, right?
Yeah, right now I'm not doing anything, so it's like it's like a Go program, it's a networking thing.
So it's just sitting there with a socket open, maybe.
Yeah, I don't know if Kubernetes is not available. This EKS Anywhere, right? And that doesn't have it.
That was the last point I wanted to show. This is EKS Anywhere, so this is this could be anywhere on-prem environment where if you don't have the benefits of shifting workloads into AWS, using Lambda, using a hosted service from somewhere, you can use something like EKS Anywhere, put Knative on top of it, and actually get the same experience in your data center, which is pretty killer.
Really cool.
Yeah. Let me show the if then that Knative eventing example. So I have an OpenShift cluster running in AWS, and I installed the source. You talk about sources. There's sources for everything. Even TriggerMesh has a lot of sources. So this is a source that is monitoring a S3 bucket that I have here. I created one called sysantana PR. And then it's sent it to the broker. So this thing in the middle is the broker. So if an S3 file shows up, send it to the broker, and then the trigger we talk about, send it to this service. And it could be a Kubernetes service, like I said, or it could be a Knative service. And this service, I just created a little snippet of code saying parse the cloud event and then send a Slack notification. So if I move over here, I have the AWS CLI in here, and I have a file. Let me move to OCP called CE, and I put a filter saying not every file that goes to the bucket, but the ones that start with CE, just like something random that I put in there. And I can say, welcome, Chris, put in here, right? And then I can go and move to that environment. Let me move to the OCP, and I can do the AWS copy, and that file went to my bucket. You won't see it here because the source grabbed, and I hear something in Slack, and if I open my Slack, you will see down here says, welcome, Chris, right?
Wow.
Something like that, if done that. This is a dummy thing, but Usually people use this type of systems for like, processing thousands of requests or cloud events for like insurance information, from insurance claims, or data from IoT, from parking meters, right? But that's the event-driven application use case. Like very simple to have a trigger defined in. Let me show the trigger. I think I'll show that last thing. So you search for trigger here, which you have a trigger.
Mhm.
Let me see, where is my trigger. Uh, I don't find my trigger, but if I go to
What namespace did you leave it in?
kn get, I used to see a line triggers. Triggers create. I created one for Telegram also. Um, you will find that I have one that says Slack. If there's a message in there, send it to the Funk one, right? I'm also doing one for Telegram. If you send them another cloud event, instead of sending to Slack, send it to Telegram, which is like a mobile chat app. So that's basically the trigger information for that.
And for me, like real world cloud events have worked for various things. We used to use EventBridge to scale up and down clusters, or to remove nodes from a cluster. And we could say, oh, I got an event from an external source, where we'd get events from Datadog, or we'd get events from CloudWatch, and we'd send those onto the bus, and then we would act on those with Lambda or with something else, and we would send that over the EventBridge. So that was like fully AWS hosted. If everything you have is in AWS, it worked great for us in the past. And in this case, you can do that in a self-hosted environment, or environments that maybe on-prem or don't have all of that functionality. And you can say, hey, I need somewhere I can send the events that can buffer it and make sure that the delivery is reliable, and then some way to trigger that. And whether that's a custom function or sending it to the Slack API, in those cases, like these are all valid solutions for, hey, I just need something to push over this information or do something on when something happens. And Carlos, I actually don't know, does Cloud Events have batching? If I say like, oh, wait for there to be 5 triggers, or wait for there to be some sort of like time frame to actually do action on this.
Well, cloud events, I don't think. Well, I'm not sure. I'm not familiar with if cloud events does that define that spec. Cloud events is just a spec.
Yeah, it's just a
It's
spec.
not
So it wouldn't
implementation.
implementation. Yeah.
At least for ours, if you use Kafka, for example, it's very high performance, right? And we go there. The good thing is the concurrency, right? We go back to the concurrency. So if you get a lot of messages, you will handle one at a time for every HTTP request. But I can find out if we support like batching, instead of like send me the events like 5 at a time, things like that. Not sure if we support that, but I'm sure like you talk about things about delivery. So in that triggers, you can say send that cloud event to this function, or my Knative function for Slack. And it could be that my function, my service is busy, right? And if you need deliverable mechanisms to like dead letter sync, like what happens in my I forgot to I have the Telegram one that I janked out, and it was saying it was not true. Where do I send that event? So you can set a dead letter sync to send it to another place. You can do retries or exponential backup. So this is built in, not something that you have to. Usually, I used to build system like this, so you have to build this into your code when you're calling something that can have rate limiting, or is down for a few seconds, or retries. The broker with the trigger or dispatcher will handle that, and then you are in charge of saying like, what is the policy that you want? You want linear or you want exponential to do that? And just wanted to point out this, which is I think it's very cool, is when you call a function with your cloud event, like my Slack app, which I wrote in Node.js, I can either return with a HTTP 202 like empty and be done with the transaction, or you can reply back with a new cloud event. So you can take a cloud event and then like take data from it and create a new cloud event with a different type, a different source, different data. and you respond back to that HTTP request with a cloud event, and then this it will go back to the broker, and based on the filtering, it may go back to trigger two, because trigger two is listening for these cloud events that have this property or extensions, and trigger two may say, oh, I see a cloud event that has this property, send it to handler two. So you can have a chaining mechanism of saying, or chaining or transforming cloud events, right? Or producing more cloud events, which I think is very useful when you want to do something with the system, not just like end the transaction, but like continue with the transaction with the transformation. Maybe I augmented the cloud event with more data, right? Maybe a quota ID, or maybe sales ID, or maybe a person dealing
Existing
with the
customer
insurance
versus
company,
not.
right?
Yeah.
Yeah, or phone number. I just create a new cloud event with that information, and then I send it back to the system, to the hub or to the mesh, and there might be somebody else listening for it. Or it can
And
come
that,
next week and listen for it.
yeah, that brings me to this final kind of question that we can wrap up with. One thing that, from what I've seen already and have known, that, wow, am I lagging? Everything is frozen for me. Hopefully my audio's still there. Okay, I see myself again. Anyway, that was super confusing. Something that I see that's a little different here is, oh man, why is this? There we go. Now we got a layout. Sorry about that. How does Knative compare to Lambda? And from what I've seen, Lambda allows you to do that one-to-one function only, trigger it. There are different ways to trigger those Lambdas, which is great. But Knative is kind of a step further than that, where Knative also does things like AppRunner does, where I can share some of my connections, my things that are triggering my events that are triggering, or requests that are triggering my function or application. I can send 100 of them to the same container inside of AppRunner, and get multiple things going to one piece. But also with the eventing part, I get other benefits like I would have with EventBridge, and even with step functions like you were just describing. In that case, like step functions allow me to take a bunch of lambdas and glue them together in this sort of, business logic of like, I need to do this and then that and then wait for this thing. And you can do that with Knative and Cloud Events and say like, oh, each function is still just going to trigger a piece of the larger pie of what I'm building, but I don't need to build one monolithic app or a large function. I can break that up and then make it be pluggable, so I can inject right into the middle of my function routine, instead of trying to go directly from the top and then waiting for it to filter down. So there's a lot of other things that Knative's bringing that tie together these other pieces of what you would get completely native in AWS or other systems. And I think my video is finally catching up right now that we're at the end of the stream.
Yeah, I added here the functions topic because it comes a lot. When we created, the project started, we wanted to be like a serverless containers, right? Not functions related, but a lot of people want to have that abstraction. They want to write like in code, write a function, and not write like an HTTP web server. Maybe they're not familiar writing a web server. So we have a CLI plugin called Funk that you can do KN Funk, and basically has templates inside with a signature of cloud events. So it will give you like a Python and Quarkus and Java and Node.js that either handles an HTTP request or a cloud event, and also helps you build the code. Like behind the scenes, you do Funk deploy, and it will build you the container using build packs, and then create that signature and create a function. And another projects, and there's a lot of projects like now that Knative is there, it's like we build on top of Kubernetes. Those other people are building on top of Knative. So wrapping that function inside a container that listens on port 8080 is very trivial. But if you provide something in your company or you provide an open source project, so Trigger Mesh did something called LR, I think it's called Knative Lambda Runtime. So basically, you can take the code from a Lambda function and put it into a folder, and then they run their CLI that will create a Knative container, but it's just a container that listens on 8080 that handles a cloud event, transforms that cloud event to the expected one from Lambda, and then replies back with a cloud event. So it's like putting a web server around your code of Lambda. And then OpenFast is something that I experimented with. I took an OpenFast function that listens on port 8080 and then just deploying Knative, and I was able to send a HTTP request with a post and it replied back. So that's kind of like the neat thing, that people can build on top of it and gain that scale to zero, or gain that ability to run these like in Minikube, right? For example, to learn how to start getting started.
Yeah, cool.
Awesome.
I learned a ton. Thank you for joining us, Carlos. If anyone wants to reach out, we all have our Twitter handles. If my video catches up, I'm trying to point at myself. There it is, wherever that. You can reach out on Twitter. I'm also interested, if you're joining live or watching the recording, ping us online to talk about what you would like to see next year. We're currently, it's the end of 2021. We're already planning 2022 shows and some of the big topics we want to cover. So reach out if there's something specific you want to learn or want to look into deeper. We can get some guests on the show. And I'm really excited for what we got planned. So thank you again, Carlos. Thanks for Chris for coming on your first show. And thank you everyone for joining. We'll talk to you later.
Yeah, thank you for having me.